Battley, who's going to talk about lambdas and fear.
Yes.
Round of applause for Paul.
I'm sure my slides will be up in a minute. I'm glad that Tom went earlier, because he's given some really good reasons to actually fear all this stuff. That was properly terrifying. My talk is... James? Tom?
This is better than your talk.
Yeah, I know. Sorry. It's much more boring. Anyway, yeah, so I'm not really going to talk about the Lambda calculus or anything kind of computer sciencey like that so much. Not specifically, anyway. I'm more talking about kind of blocks and procs and lambdas in Ruby. And those aren't all exactly the same thing, as Tom said. I'm not going to worry about what the differences are. Basically, the return values are slightly different, but for the purposes of our presentation, we're not going to see that, so it doesn't matter. So all that really matters is that everything looks kind of like this. They take some parameters and they return a value. And you know, you'll see different kinds. They're all kind of parameters and a calculation. You could have one parameter, two parameters. They might even have some nested parameters like that, and we'll see an example of that later if you iterate over a hash with inject, for example. But anyway, so what I'd like to do is to set out some sort of ground rules for how we can use this functional style to make our code slightly clearer and to avoid going wrong. So the first one is, if you're returning a value, use the functional style. And the corollary to that is when you have side effects, and I'll explain that in a second, use each. So don't cross the streams. You know what happens when you cross the streams? It destroys the universe. And in our case, well, the universe will be okay, but your program will be worse. But finally, although I've said use functional style for returning values, if it's really complicated, stick with each, because the kind of zeroth rule really is whatever you do, don't make your code more complex. And I've got a couple of extra rules of my own. I tend to use the curly braces for functional stuff and do-n for imperative stuff. And either way, you certainly want to use curly braces for functional stuff because the precedence works very well for chaining. And I'll show some examples of chaining later. So what are side effects? Well, a side effect is basically any change in state. Writing to a file, writing output, could be writing a template, that kind of thing. Code that has side effects is described as impure, and code that doesn't is pure. So, kicking ass and taking names. Taking names is pure. It doesn't change state. Kicking ass, on the other hand, if you're doing it right, should change the state of the bad guys. So once we've done that, we can find out who's still standing, but that's pure. So that's all fine. But if you're kicking us and taking names, don't mix them together. See, we're taking the names here, but we're kicking us at the same time. Don't do that. Kick us, then take names. So anyway, why does all this really matter? Especially since we can't actually write proper pure code in Ruby unless we go to the sort of extents that Tom did earlier, in which case it's not tremendously efficient. Well, there are some kind of concrete reasons that, that we might want to use these constraints. We can have better composability. We can get better maintainability as well. And pure functions tend to be easy to test because they depend solely on what goes in and then stuff that comes out. Easy to write a test around that. But actually, I think there's another reason, which is people often, I think, because a lot of programs come from a kind of imperative world, functional stuff is often perceived as being quite complex or quite difficult. But actually, we can use it to make our code clearer. And I'm going to try and find some examples of this. So, at the same time, one of the things about making things clearer is I want to talk about variable names. And this is slightly controversial. I actually want to recommend that you use single-letter variable names some of the time. Not all the time, but if we take this example, the top line, things.map, things.upcase, got a lot of repetition of thing, and actually it's the upcase that matters. And in fact, a good choice of mnemonic can tell us there that actually it's probably a string. And because it's all in one line, I think that's fine. Context is fine. If you're going over more lines, then it becomes more important to keep the meaning of your variable in its name. So some rules that I use for single letter variable names are this kind of thing. So ABC, use F for a file name, use S for a string, or just use a mnemonic of the first few letters. Hang on. Sorry, that's in the wrong place. That's why I'm confusing myself. Right, I'll just go back to that later. So I'd like to introduce you to the good guys, really, in this presentation, which is really, it's all about enumerable. And you might not be familiar with enumerable. It's a module from the standard Ruby library. And if we implement a class that has two methods, well, actually, we can get away with one method. The only one we really need is each. So if you define each, then enumerable gives you a whole load of other things like map, inject, what else can you get? Sort by. But if you want to use sort or max or min, then you need to define what's sometimes called the spaceship or the flying saucer operator. And that lets you compare two things. And if you define these two, then you can get everything from enumerable for free. So it's quite nice. So what does enumerable give us? Well, big one is map, which takes all the stuff that we put in, applies some kind of function to it. In this case, where we take each word here, find its length, and we get the length of each word. That's fairly simple. I hope you've seen that quite a few times. Flat map's an interesting one that's new in Ruby 1.9. So here we might, if we've got an example of sort of some tags, and we want to find all the tags in the different documents, we might split them, and we get a kind of array like this. But if we flatten it afterwards, then we can get down to all the tags on their own. Well, flat map's kind of the same thing, except it does it straight off. It's not a huge win, but it's a common thing we might use, and it's nice to have one word for it. So inject. I don't know if anyone remembers Zombocom. Anyone remember Zombocom? What can you do at Zombocom? Anything. It was an early Flash site on the, I think. But yes, you can actually do anything with inject, which is good and bad. So if we want to find 5 factorial, we can inject over it starting at 1, multiply each time, and the output result of each block goes around into the next time, and so we build it up, and you can see kind of how it works down there. There's actually, if you really know inject well, you might realize that 1 isn't necessary, but that's a complexity that we don't need to deal with. The trouble with inject, though, is that because it's so versatile, it can be quite confusing. So other stuff we've got, there's all, any, none, and one. And these all tell us, for example, if all of the things in the enumeration match a particular set of constraints, or if one of them does, or if none of them do, or if any of them do. They all work in pretty much the same way. Detect is also known as find, and I've chosen to use detect today because find is used in active record a lot, and it has different semantics, and I don't want to confuse things here. So detect simply returns the first item that matches a particular set of criteria. Then select is similar to detect in that it returns all the ones that meet the criteria, and reject is its evil twin. It gives you everything that didn't match. Now, you may be familiar with sort, but sort by is a far better thing. So sort by is both more efficient and shorter. So if we've got a list of mustelids, the small kind of animals, we can sort them by length, and all we have to do is calculate the length once. And internally, Ruby is quite efficient at dealing with this, and it's quite short from our point of view too. Take while is kind of like select, except it's rather pessimistic. It gets put off easily. So it gives up as soon as it can't find anything that works anymore. So if we're looking for things that contain the letter E, select will give us all the ones that contain the letter E. But take while, on the other hand, gives up at the second one because it didn't have an E in it. That can be useful, though. Zip is kind of like the thing that fastens your trousers together. It takes two sets of enumerable things and zips them together into pairs. And there's a slight irritation with this, which is that the parameter that you pass into zip has to be an array. It can't be an enumerable. And that's a side effect of the way that Ruby works. Ruby isn't really like functional languages in that respect, so it's slightly limited. You can't, for example, have an infinite range there or something, which would be really nice. So to recap, these are the kind of things we've got. And I've put a star next to some of them. And those are the ones that don't necessarily have to go over the whole array or the whole enumeration. So for example, if you ask for all, well, the first thing, if the second one doesn't match, it can stop there. So if you can actually demonstrate that yourself by using an infinite range. And it will actually, and this is the one that I had in the wrong place earlier, and that will actually work. So 1.0 over 0 is infinity. If you ask for all of an infinite range, but actually it only gives you up to 10, gets to the 11th, well, gets to 11, says that's or actually 10, says that's greater than or equal to 10, and it gives up. So that's quite useful if you don't want to go the whole way through something. It's quite efficient. Right, so I've given you a kind of a brief tour of some of the methods in enumerable. There are others as well, but those are some useful ones. And now I'd like to show some examples in the wild of bits of code. And these bits of codes are generally things that use kind of imperative styles of coding, but which I think we can improve. And some of these bits of code, because I have taken them from real applications, they have other kind of flaws or infelicities. I'm only going to look at the iterative part of it. So I don't make any claim for these solutions I come up with being the best solution, simply picking on the kind of functional bit. So here's a common thing that people do, finding the first match in a set of items. So here's a bit of code. It's got some filters. It's filtering them by filter type. Returns, if it finds one whose filter type matches the filter type that was passed in, it returns it. Otherwise, it returns nil. Well, that's a one-liner in Ruby. It's much nicer. We know what detect does. We've actually lost a whole load of noise around here. And comparing to this, there's a lot less to think about when we look at a piece of code like that. So that's a really nice, quick win there. Another example, which is very similar, is does anything match? So, got a load of categories. Go to find out if any of the categories corresponds to that category, otherwise we return false. Again, that's really simple. Any. The clue's in the name, really. That once we start thinking about what this code does, there's actually a method in enumerable that does what we want. So a slightly more complex example now. This is probably, particularly if you've listened to first Tom's talk this morning, you'll already think this is slightly dodgy code. I'm going to ignore that. What I'm going to do here is to take it down to a sort of platonic form so that we can actually think about just what the code's doing, which is basically starts off with a string, keeps adding stuff to the string, and then outputs it. In fact, because I've put in a constant there, I should probably have duplicated that because it's going to mutate it. But that's OK. We'll work around that. So what we can do here is that instead of just appending stuff to the string every time, which is actually not all that efficient, but more than that, there's a lot of extraneous noise there, we can map it. So we can also realize that on the first line, instead of checking the length, we can use any, and any with a default value just tells you if anything is truthy. Yeah, so if it's not false and not nil, it'll be OK. And then we could sort of join the things with a map and a join. That's a bit shorter compared to that. We could even go further, and we could use inject. But as I alluded to earlier, inject can do anything, but it's often not at the expense of clarity. And again, here we're actually appending to a string each time. We've got the output kind of accumulator variable has come back. It's not really any better. So I'd probably stick with this one for myself. Okay, another example of an accumulator with an array. So this seems like a kind of straightforward thing, right? We've got an array of stuff, iterating over some filters, turning them into a little sort of hash, and then appending them. And we might think that we can just do this with a map, but the second part, the is reciprocal bit, is kind of a complication that makes it really difficult to do this in a functional way, at least whilst preserving clarity. So we could do something like this using flatmap in Ruby 1.9. You'll see at the bottom that's a reminder of, sort of what flatmap does. But really we've added a load more different kind of logic, and it's not given us a lot of advantage. So in this case, we can't really do anything. We should probably stick with this. A hash accumulator. So you might have seen things like this before. It's quite complicated, so let's strip it down to the kind of platonic version. We've got some fields to clone. On each one, we're doing a merge. So merge bang is the merge with side effects. It mutates the new attributes, adds this key and value to it, and then finally the thing gets updated. Well, we've got a couple of options here. So in Ruby 1.9, we could use the hash like this. The trouble with this is it's not particularly clear. And in Ruby 1.8, it gets even worse, because Ruby 1.8, you have to have this kind of input. So we have to flatten it and splat it, and really that's not an advantage at all. But we could do this. So in this case, we're using an inject, and on each turn, we start off with an empty array, and we merge it with f, send f, gives us a new array which has this extra key and value. So that's quite nice, and it's quite pure as well, but it's not tremendously efficient in Ruby. So we might actually want to cheat a bit, and given our sort of start value, just mutate it and then return the value. That will mutate it in place, and it will be both fairly short and quite efficient. So I think if we compare that to that, we've got a nice sort of simplified version. So an array accumulator again. This one should be obvious. This is actually a poor man's map, really. There, easy, one line. How? This is a beast. It's got not just one but 3 accumulators. So there's some of the kind of the things that should be giving us pause here are the fact that we've got some numbers, checking the number of the iteration. This is slightly fragile logic. It's not immediately obvious what it's doing. And we've got a whole bunch of accumulators that are then sort of put together at the bottom. Well, it turns out that this is actually really simple, this code. We can do it as that. We can map each key to the like term. We can join them with and join only puts in the ands in between stuff, so we don't have to worry about keeping track of whether we're on the last element or the first element like we did before. And then our values, we can just map them with a % sign on each side, add the 2 arrays together, and job done. A complex nested hash. So this is some code that builds up a list of which months of which years and how many blog posts there are. Let's simplify it a bit to that. So this is kind of what it looks like. One thing we can quickly do is to notice that we've got this sort of setting the first level of the hash to an empty array if it doesn't exist. Well, we can do that automatically with the hash default. Hash.new will also let you pass in a default as a direct parameter. Don't do that because you'll get exactly the same object and you'll end up adding them all to the same item each time. So you need to use this kind of idiom. So that's slightly shorter, slightly nicer, not a huge improvement. We could start trying to get clever. We could maybe do this with inject. Is that clearer? Not really. How about this? Yeah, don't do that. This is I think the place to stop in this piece of code. The subsequent ones either take the same number of lines and make it less clear, or are so ridiculously terse and no one's going to really know what that's doing. So here's an example of something that actually I've taken kind of from the battleships thing that we did at Elrug the other week. Although my example here is a blur. So if you know how blur works in a kind of in Photoshop or any kind of image processing, it does what's called a convolution. And we take a kind of kernel, so there's our center point is a 4, 2, 2, 2, 2, and then 1 on the corners. So we're adding together pixels around the pixel we're wanting to update, and we're weighting them differently. And so and if our image pixels are that, then we end up multiplying them together and then dividing them by the sum of this side to scale them back to the original value. So a kind of naive implementation of that would be something like this. Start off with our sum, start with our scale, a 0, iterate over the rows, iterate over the elements, find the value at each point, then add the two things, and finally return a value. So the first kind of insight we should have here is actually that we could make it simpler if these were not nested arrays. So if we flatten them, we could do something with inject. And if you do inject with plus, it gives you the sum. In fact, if you're using active support, you could just do .sum there. It's not in Ruby as standard. And then we want to take the flatten them down, zip them with the sample. So if you recall, that gives us the two things as pairs. And then we can just multiply them together, adding each time, and we end up with one calculation at the end. So that's quite a bit shorter. It's a shame, really, that there's not a good name for this in Ruby, or this, or some. We could, if we wanted, give this lambda a name, and that might make it clearer, but I don't think it's too bad. Now, let's go too far. This is something that I wrote. It made sense to me when I wrote it. Then I came back to it about 2 days later, and it didn't make any sense at all. Does that make sense to anyone? So I had a state which had an array of player, the opponent, and the board, and there was one of those for each player. Turned out that what I actually wanted was something like that, and that was actually the better course. So I actually reversed from this code that I initially wrote. I came back to it a few days later, asked myself what I was doing, hit myself around the head and wrote that. And then I could actually reason about it better. So it's not always the case that functional stuff will make your code clearer. You have to be really careful. So here's an example that crosses the streams. There's kind of other problems with this bit of code anyway, but it's finding something. It's updating an instance variable, and then it's returning a value. So that's already kind of sketchy, but let's at least stick with the same interface. We could find the name and the value using detect. That at least gives us one line we can return. So it's quite clear at this point what we've done. Then we could find the name using another regular expression and do the same thing. It's a slight improvement. But probably what we should find at this point when we started refactoring is that actually this gives us a clearer view that our code is doing things it shouldn't, and that maybe we'd be better off separating this out into other methods, or maybe a better way entirely. Okay, adding an index. So here's something you might often want to do, where you've got an array of stuff and you want to find out what's the 0th element, what's the first element, and so on. And the kind of obvious way to do that is to use each with index, because that's really useful. And then you might find yourself wondering, well, where's map with index? Well, you can get around it with using something like that, like a zip. It's not very clear. But in Ruby 1.9, you can get map with index. It's great. So what's this? It's an enumerator. And enumerators are a new thing in Ruby 1.9. There's a library for 1.8 that lets you use them. I think the implementation is slightly different because they use fibers in 1.9. I think they're also in JRuby and Rubineous as well. Haven't used those. But what it lets you do is, given something like each and each with index, you can do a dot map, and that returns an enumerator if you don't give it a block. And then you can call with index on that. And You can do it with all kinds of things. There's not that many in the standard library, but you can write your own. And this, in fact, lets us do some kind of interesting lazy stuff that I previously said that you couldn't do in Ruby. You actually can if you use fibers and enumerators in Ruby 1.9. But there's probably an entire separate talk in that, and I haven't seen anyone do anything too much with that yet. So, in summary, I think there's often a better way to do this code than using each and iterating over a set of things. And if you're not familiar with all the stuff in enumerable, and actually I wasn't, there's all kinds of weird stuff in there. There's min-max by, which finds the minimum and maximum items that fulfill a set of criteria that you specify. There's oh, I think I found something even weirder in there. Yeah, partition, and partition is quite useful. It lets you split into two sets. Chunk, which would actually solve one of the things that was in the Ruby code golf in about one line. So there's loads of stuff in there that you should have a look at it and see if you can apply it. But beware of inject, because in my experience, you can do anything with inject, and the trouble with that is that you can do anything and no one really knows what you mean, and you probably won't know what you mean when you come back to it. So that's my suggestions. Thank you.
Anyone have any questions?
When you were talking about naming the parameters,
yes,
the thing they can have, instead of passing it a block, you can just pass it as a symbol, and it will call the method named by that symbol.
That's sort of true. You can't actually do that in that case with the sum.
No, sorry, earlier when you were given general guidelines for naming.
Yes, that's right. I decided to skip that because it doesn't work universally, and it only works in Ruby 1.9 or if you've got active support. Right. Yeah, no, you're absolutely right. But it doesn't always work when you think it will, because it depends on the sort of arity of the method. So there are things where you might want 2 parameters and it expects 1. So plus, for example, it doesn't.
You can do that with inject to shorten that sum.
Yes, yeah, that one is very, yeah. You can also replace 2a with inject with a square bracket and the Cthulhu operator, but.
The example that you gave of the hash constant square bracket method, where you can call
yes, yeah.
I was surprised when you said that only works in 1.9, and I tried it, and it does work on 1.8. And I would encourage people to use this.
Oh, sorry, do you mean...
yeah, that one.
This one?
That one on the bottom.
This one, really?
Yeah.
Maybe that was 187 then.
Sorry?
Maybe that's 187. I'm pretty sure.
Yeah,
right, so yeah.
So I think a good rule with inject is don't use it unless you're actually accumulating something, like unless the thing that you're doing in the block actually depends on the previous results. So if you're just using inject to build up something where the elements are independent of each other, then you should probably use something else. So that method, the square bracket thing, is very useful, I think.
Oh, if that does work in 1.8, then yeah. Personally, I tend to use this quite a lot, but I think it comes to quite a cost of clarity. I think this is not. I think it looks quite weird compared to what it does. So, yeah, I like it, but I think it's not actually not very clear.
There's something that you do a few slides back, which I think is a bit of a functional anti-pattern.
Oh.
Where
I'm happy to be.
You're building up a hash with inject,
but
then you're setting the value. You're setting a value through the square bracket. With the key,
yes.
You do semicolon A.
Yes. That was the if I can find it. This one. Yeah. So actually, this is the nice kind of functional one, or actually that's the really kind of efficient one. Right, yes. That's the kind of nice functional one where it's pure. The trouble with this is that the data structure the data structures in Ruby are not, they're not functional data structures. So you end up building a new hash each time. So in this case, it probably doesn't matter because there's not that many of them. But generally, that's relatively inefficient in terms of creating lots of objects. Whereas that just updates the same object each time. I know it's not as nice, but it's not Haskell.
On that note, actually, it's worth pointing out, I think this is an active support thing, but I think active support comes with a kind of mutating version of inject called injecting, in which it doesn't matter what block returns. You can just mutate the accumulator object and then carry on. So it will basically
surely the functional programmer should be descending on them with pitchforks at this point for an impure version of inject. Yeah. No, there's actually quite a lot of useful stuff in active support that. I do lots of stuff with plain Ruby objects that doesn't use active support, so I tend to try not to rely on that. But if you're on a Rails app, then yeah, there's loads of stuff. Sum, for example, is really nice to have. It's much nicer than injecting. Yes, in group sub, which is basically like iterating over an array with a hash and setting the default item to an array and then appending it to the array, isn't it? Yeah, it's quite nice.
You can maybe combine both best of both worlds by you go back one slide. Just page merge exclamation mark.
But that returns. Actually, I'm not sure what merge bang returns.
Doesn't return it.
No, that's what I thought. So you'll get lots of nulls. Yeah. So some of the bang methods like sub and things return the value if it match, but merge bang doesn't.
Yeah, you're right.
Yeah. Yeah, that's the siren call of your side effects, but yeah.
Any other questions?
Cool. Well,
When I came out of maybe it was doing something as well, the re-index method, I was quite excited and I was looking forward to using it. But so far I've only ever used it with map, I think, maybe one.
yeah, well, you can use it with each, but actually .each on its own in 1.9 is exactly the same as .map. It just returns an enumerator.
But do you have any examples of neat things you can combine with index for?
I did see I saw a blog post where someone had used the enumerators to make a lazy version of, I can't remember what it was. Maybe it was like something, but that was genuinely lazy. And you should, with the enumerators, be able to do the zip with an infinite list, potentially, because the thing that prevents that from happening in Ruby standard is the fact that the control is in the enumerator, which is responsible for the iteration. So it's not possible for you to iterate through two things simultaneously. But with Ruby fibers, it is actually you can have these two separate fibers, I guess, of execution that are cooperating. So there are really interesting things that can be done with it, but I haven't seen anyone really do it yet. It's kind of new, maybe.
Anyone?
Thank you.
Round of applause for Tom.